today we are going to do area of a regular polygon. So this is something you have not had before. Now regular means that it has the same angle measures and all the sides are the same length. So what we do here doesn't apply if you don't have a regular polygon. So the first regular polygon that should come to mind is an equilateral triangle. And all of those would have the same side. And let's say that this is 8. We want that area there. Now what's the area of a triangle?
8 is
Based on size latitude.
Yes. Okay, so what am I missing here?
The other side, your height.
I'm missing the what, Kip?
Height.
The height. I need an h. Well, how can I get that height? Well, if this is an equilateral triangle, what are all the angles? 60. Okay. Now can I find the height?
Yep.
Okay. Call it out. How do I do it?
You do sine of 60
equals
x over 8. Yeah.
Okay, so trigonometry, fair game. Alright, what do we get to the nearest hundred? If that's even necessary, I don't think it is. What do we get?
You get, well,
6.9.
yeah.
Oh, sorry, 6.93.
Okay. Alright, now we can find the area. So the base is what?
The base is
8.
8. How do we know that the
Because
base
it's an equilateral
is 8?
triangle.
It's an equilateral triangle, which means this side is how long?
8.
And this side is how long?
8.
And this side is how long?
8.
That's what an equilateral triangle is. So all the sides are 8.
Okay.
What's my height? 6.93 to the nearest hundredth divided by 2. So what's our area approximately to the nearest hundredth?
27.72
units squared. Any questions how I did that equilateral triangle? I guess not. Let's extend that then to a pentagon. Since it's a regular pentagon, I know that all the sides are the same and all the angles are the same. This one's going to be trickier than the equilateral triangle, however. Let's say this side is 12. So all of these are 12. And give me some ideas of what you think you could do to find the area.
Divide it up into triangles.
Okay, divide it up into triangles. So let's just take one triangle as an example.
It should be an equilateral triangle.
It should be an equilateral triangle, you think?
Possibly.
Yeah.
What if you split it up into a trapezoid and then a triangle on top and you split, am I overcomplicating it? Because you could have two triangles
So
on
could
top.
I divide this into a trapezoid and then have a triangle as a roof?
Yeah,
I could.
but then you don't
You're,
know the...
but what we're trying to do here is see if we can figure out a way to do it for every single regular polygon. So let's stick with doing triangles.
Would it be
Okay,
half?
because we did triangle here and we did triangle here. And what are you saying, Victoria?
Would it be half of 12?
What would be half of 12?
Because you're going to the center of the green lines, would it be half of 12?
I don't think so. That doesn't look like
I think
6.
So if you're trying to find the area of that, if you find the area of that one little triangle, can't you just see that it makes 4 other triangles and multiply it by like 5?
But we don't have the height.
Huh? Well, I mean,
Okay, so Evan's saying find the area of that triangle. So let's pull the information that we know for certain of that triangle. We know that its base down here is 12. And then he's saying find that area and multiply it by 5. And then Daniel says, but wait a minute, what do we need?
Height.
We need a height in order to do that. So the question is, could I figure out that height? from one of our previous chapters, well, before we get that, we're going to need to know an angle, aren't we?
Yep.
Yep.
Okay. So there's lots of different ways you could get an angle in this triangle. Let me name two of them. One way is to find these angles. And we have a formula from a previous chapter where you could get that. It would be 180 times n minus 2 divided by n. That gives me that angle. Okay? So that would be half. This would be half of that, right? You with me?
Yeah.
Okay, raise your hand if you're with me. Show me you're with me. That you understand. Okay, so let's do that. Let's do it that way. We have 180 times n minus 2, so that's going to be 3, and then divided by 5. And what do we get for this big angle right here?
108.
108, but see, that would be this. So I've cut it in half, so what is that?
54.
54. So that gives me that angle. I think that's the long way. How many degrees, if I put this, and you're actually going to have to get familiar with this terminology later anyway. If I inscribe this pentagon inside of a circle, now you don't have to draw this, I'm just explaining how I'm getting what I'm getting. So it's inscribed there. How many degrees are in a circle?
360.
360. Now I've cut how many triangles out of that?
5.
5. So do you see which angle I'm about to look at?
No.
If it would let me draw, that would help. Do you see which angle I'm looking at?
Yes.
Okay. So I have how many degrees in this circle?
360.
And I've cut it into how many pieces?
5.
So 360 divided by
72.
5 is 72. So this whole angle right here is 72. Raise your hand if you're with me.
Yes.
So we just did 360 divided by 5 gives us that inside angle right there. Okay? So I have a right triangle. And I found two of the angles. Now I don't need to find both of them.
What? 54.
I really just need one of them. Now I want this height right here. So that 72 is the whole angle. Half of it's 36. You with me?
Mm-hmm.
Okay? Now I dropped this down. Now this is an isosceles triangle. How do I know? Because I have a radius here and a radius here. So I have half of it. So this would be 6. So what is it I want to know? I want to know this height, don't I?
Yes.
So I could either use that 36 or that 54. You're going to do whichever one makes sense to you to figure out. Okay, I think the 360 one is the fastest and easiest, but it doesn't matter which one you use. Alright, so I'm going to find that height. I have opposite and
Adjacent.
adjacent, which is
Cosine. Oh, sorry.
opposite and adjacent is tangent. So tangent 36 equals 6 over h. Multiply by h.
6 divided by 10 to the 6.
So wake up. 6 divided by tan 36, and what do we get to the nearest hundredth for h? 8.26. That. Okay, there we go. 8.26. So now I can find the area of that one triangle. What's the area of that one triangle? Wake up. What's the area of a triangle?
Base height over 2.
Okay, what's my base?
24.78. Oh, that's the answer. But your base is
What's my base?
6. 6.
12. Thank you. What's my height?
8.6.
Divided by 2. What do I get for the area of one of those triangles?
0.56.
49 point what?
56.
Now, I'm going to multiply that by how much?
5.
5.
247.8.
Okay? So what was our final answer?
247.8.
Units squared. Do you get the sense that no matter what shape I have, I'm always going to end up finding this thing right here? Okay, I hope you get that. I don't want to go through that proof again. That's going to lead us, that happens so much that we have a special name for that. It's called the apothem. So in any, let's do a hexagon. So in any regular polygon, the distance from the center of that polygon to one of the sides, the perpendicular distance, that's the apothem. We call it A. So that actually leads us to a formula that will happen. The area of a polygon is the apothem times the perimeter divided by 2. Now that's if I'm given the apothem. I'm not always given the apothem. Sometimes I'm given something else.
So could you do that little circle strap for that one too?
Well, I'm not going to need to because I'm going to give you some information.
Oh, okay.
So let's say this is 15, and let's say the apothem is, I don't know, 8. I'm just making up some numbers here, just for the heck of it. I have a side, and all these sides are now 15. So I'm going to use this formula. I don't need to calculate anything because this formula gives me that. I do need to find the perimeter. What's the perimeter of this shape?
15 times 6.
6, because it's a hexagon.
90.
So 90. Okay, so remember what we just did. We had how many triangles would I end up drawing in here? 6, right?
Yes.
So 6 of them.
So the triangles
Perimeter.
are only how many? Or the no.
So the apothem is 8. The perimeter is 90 divided by 2.
170 divided
The area is
by 85.
okay, units squared. Whatever our units happen to be.
Wait. I think there's a problem. 360.
Yeah,
360.
260. I was like,
360.
what?
8 times 90.
Okay, so 360.
It's
Yeah, I just figured. it
Okay,
out.
going on. Let's say I have an octagon. How many sides is that? 8 sides with side equal to 20 and apothem equal to let's do 15. Just make up a few numbers. Alright. How do I do it?
You do area of a polygon equals apothem times perimeter divided by 2.
So I have 15 times, now my perimeter is not 20.
It's 20 times 8.
My parameter is going to be
160.
20 times 8 because I have 8 sides, so 160 divided by 2. Units squared? Is that what I heard?
Yeah, units
Okay.
squared.
Okay. Now sometimes I'm not given much information at all. In fact, it would be very rare that you're given the shape, the side, and the apothem. You probably only be given like the 2 of those things, and you have to figure out the rest. So let's start with the easiest of that possible case. Let's say I have a triangle. Or maybe I'm not given any of them. A triangle with radius equal to 9.
Radius is
And you're thinking, wait a minute, a radius is only in a circle. You are correct,
You draw a
except I
circle.
could have a circle around this, in which case the radius would be from the center to there. And that's 9, which means all of these are what?
9.
9. Alright, now I don't really need that circle there, so I'm going to get rid of it. Okay, now this is a regular polygon, which means all these sides are the same. So let's think about our formula. Our formula is apothem, I don't have that, perimeter, In order to get perimeter, I need the side length. I don't have that. Divided by 2. I have nothing. Okay?
2.
I have this radius right here. So there are some things that I could do to get it. All of these problems are going to come down to thinking. And you might find different ways to do it. I'm going to show you one of the ways that stays consistent with what we have just done. I'm going to complete this triangle here, and I'm going to find this angle right here. Well, what's that angle? Well, 360 divided by how much?
3.
3, because I have 3 triangles right there, which gives me an angle of 120 degrees. Okay? Then I'm going to draw in my apothem. See, this is my apothem right there, thus making a right triangle. So do you see the right triangle I've just made?
Yes.
Okay, so what would then be this angle right here?
60.
60 degrees. Okay? What's this length right here?
9.
That's my 9. Okay, so I pulled this triangle out. Okay, and then I want to find this side length right here. Now you could use the law of cosines, by the way, to find this. Okay, but I have a feeling none of you want to do that. So that's why I'm using this right triangle. Okay, so I have opposite and hypotenuse. Okay, so that's going to be
Sine of 60.
sine of 60 equals, I'll call that x over 9. So x is going to be 9 sine 60. Now I need to be careful. Did I find this whole side?
No.
No, I did not. Okay, so multiply that out. What do I get?
7.8.
Give me to the nearest hundredth.
700.
Yep. 7.79.
Oh, sorry.
Okay. Now I need to multiply that by 2 to get me my side. So what's my side? To the nearest hundredth.
15.
Yep.
Now what we would probably want to do is rather than round at this step, we would want to round at this step. Okay? Anyway, we'll just take it. So that's my side. Now I need to multiply that by how many?
3.
3. That's going to give me my perimeter. So what do I get for my perimeter?
46.74.
46.7.
4.
7.
Okay, whatever. We need to agree on rounding at some point in life. All right, apothem. How am I going to find the apothem?
You gotta find the other angle, the bottom one.
I'm going to have to find
Cosine.
this. What do I use?
Cosine.
Sine.
So cosine of 60 equals,
Y over 9.
sure. So 9 cosine 60 is our apothem. So what do I get to the nearest hundredth?
4.5. It's 9 halves.
All right. So what do we get? What's our final answer?
I'll let you do the calculations, Jacob.
Okay.
Okay, what's our final answer? You have calculators, so you should be done.
Where's
105.17.
Units squared. All right, I'm going to do one more example because these are time consuming and I could spend the whole class giving you examples and then you never practice. You have to practice. All right? So, let's do one more. Let's do a hexagon. The key here is dividing things up to get apothem and sides. All right? In this case, I'm going to give you the side. I'll say that the side is 15. So that means if this is regular, now you can't do it if it's not regular, so then you just, we're going to assume for this section, even if it's not marked, that it's all regular shapes. Alright, so we need, in order to find the area of this, we need the apothem, the perimeter. I can get the perimeter pretty easy. 15 times what?
6.
So the perimeter is 90. So 90. Alright, my apothem. I need to find my apothem. So I'm going to divide this up into some triangles. So I'll draw my center. And since I'm using right triangles right here,
You're going to half it?
yep. Well, I just need the apothem, so I really don't care. This side length right here is what?
7.5.
7.5. Someone had said to half it, so yep, that's correct. I want my apothem. What else do I need?
You need an angle.
I need an angle. I can find that angle that I put my little thing there, or this angle right here. I think it's easier to get that angle.
Agreed.
Okay, so I'm going to do 360 divided by,
4. No, 2.
careful,
What? 6.
6, because I have
Oh.
6. I would divide this into 6
Mr.
Six.
triangles,
Why
right?
don't you just divide it by 12 so that way you can go ahead?
You are correct. I could divide it by 12. Okay, but I'm showing you like where it comes from. So this whole thing in here is 60. I divide that by 2 again to get that angle in there, 30. All right, so how do I get the apothem?
Can you find the...
Tangent of 30.
Yeah.
Tangent 30 equals
7.5
Over
over
A.
A.
And then 7.5 divided by 1030 gets you A.
These are going to be like the death of the
okay. If you give up now, you're done. All right, so you need to. It's putting together several different things that we've done. You guys mastered right triangles. Use right triangles. Do whatever you can to find the pieces of information that you need. So what do we get for the apothem?
12.99.
12.99?
Yep. 13.
13. That's good enough. All right. So what do we get for the area?
9 times 12 is 108, so and 1 more 9.
Wait, that was supplying the height, right?
585.
No, that
Which
was
is the apothem?
585.
Yay.
585?
Is the calculation right?
Yes, it is.
Okay,
Justin,
good.
don't do that crap.
Thank you.
All right.
Decagon.
It's a regular decagon with side 10. When I'm given a shape that has so many sides, like it's just not conceivable to draw with any amount of accuracy, here's what I do. I just like, all right, here's like one spot of my shape. Okay, that was horrible.
Yeah.
Okay, here's one spot of my shape. Okay, and then I just remember that I have a decagon here, which means I have how many sides?
10.
10. So I have a 10-sided shape, and I just put a center somewhere. Okay, so if I have a side of 40, now I'm finding the finding the area. So I need an apothem, I need a perimeter. I can get the perimeter pretty easy. 40 times what?
10.
10. So my perimeter is 400. So I have that. All right. So this right here, I might draw my right triangle that I'm about to do. I need my apothem. So what's this little piece right here?
10.
Nope.
20, sorry.
20. Okay? I might have my apothem right here. I need this angle in here. So 360 divided by how much?
20.
Depending upon, you know, if you can see what Emma was saying earlier about going right to 20, because I'm going to end up dividing that by 2 later, right?
C.
But you can do it in steps. So let's do 20 though, and what do we get?
18.
Okay, so that's that angle in there. This angle in here is 18. Alright, how do I get my apothem?
And you gotta do the cosine. No, tangent.
Tangent,
What?
opposite,
Oh, yes, okay.
adjacent. So tan of 18 equals
20 over A. And then 20 divided by 10, 18.
And you get 61.55.
Ma.
61.
Yeah.
55.
okay, and I put that in for apothem. So my area is 61.55
Times 400.
times 400 divided by 2. What do I get for my area?
The apothem is
12,310.7.
12,310.7.
I can get the point.
I have a question.
Did you round right?
Instead of tangent, could we
Plus
use
it's
the
not
opposite
there.
side?
I never mind. Sorry.
12,300.
Calculator gal.
I'm so sorry.
let's listen. Victoria, ask your question.
Can we use the log cosine for subtracting your
Law of cosines applies if I have a side and a side like that, a side angle side. So in this case, law of cosines would not work. Okay? Because we,
sines?
law of sines,
Yeah.
sines.
If you found the other angle. Yeah, all you have to do.
Yes, you could do
I
the
didn't
law of
answer.
sines if you wanted to do it that way. Yes, you could. All right.